welcome everyone. Let's go right away to the presentation. Well, performance features in SQL Server and Azure SQL. So we will try to come up with an understanding, first of all, of what Azure SQL is and if there is any difference with SQL Server. And then we will try to cover as much as possible all those features that are targeted to performance, not only to improve the performance, but also to make the performance stable and predictable along the time, right? So, okay, first of all, let's put the framework of what we're going to be talking about and what this Azure SQL environment is, so we can go deeper and understand the performance features. This umbrella, how I'd like to say, is SQL servers running on virtual machines, Azure SQL managed instance, and Azure SQL databases. Those are the three main services / product that we can have in Azure. We will try to see what they are quickly, so then we go to the performance part. And recently, Microsoft added a fourth component to the Azure SQL family, which is Azure SQL Edge, which is the possibility of running SQL Server on an ARM device, like, for example, a Raspberry Pi. So this is a marketing slide, but I believe it's quite informative because this is this new Azure SQL umbrella that Microsoft would like to, start referring to, right? And do we lose all these years of experiences that we've been working with SQL Server 7, 2000, 2008, 2019? No. What Microsoft like to say here is just SQL. So all the knowledge that we carry, that we have on how to write T-SQL code or how to administer or monitor in an environment like this is completely valid, and we can use it on this environment. So along the years, SQL Server as a product has been evolving, right, since very old versions until the most recent ones, and each of them has its own, let's say, set of features that in some cases are heavily related to performance. For example, what Microsoft like to refer to is like the modern version of SQL servers in case of performance specifically, right? And those are starting SQL Server 2016, right? 16, 17, and 19, right? On those versions is where Microsoft start pushing hard in terms of performance feature to accomplish what I just said at the beginning, right? Performance features and being able to have a predictable performance. Doesn't matter if the environment is heavily loaded or if it is kind of idle, right? So we can have a performance setting that we can maintain along the way. So again, going to Azure SQL, right? The core component is virtual machines with SQL Server on it, right? Azure SQL virtual machines. The beauty of this virtual machine is that we can just go to the Azure portal, right? Go to a marketplace and select any combination of operating system and SQL Server version and edition, right? You know that since SQL Server 2017, we have the possibility of running SQL Server on the major Linux distribution like SUSE, Red Hat, and Ubuntu, right? So we can go there and select any of this combination, and we can also go back to SQL Server 2008 R2, right? Hopefully nobody is using 2008 R2 these days, but if you have to, you have the possibility. This is what Microsoft called infrastructure as a service, right? We need to maintain and support not only the SQL Server environment, but also the infrastructure, meaning the OS, the networking, the authentication, high availability, disaster recovery, everything, right? On the other side of the bucket, also Microsoft have this concept of platform as a service, right? In where they offer to us a SQL Server-like endpoint. So we only have the possibility to connect to this environment using Management Studio, Azure Data Studio, Visual Studio, but we don't know what is behind the scene in terms of infrastructure, right? Microsoft takes care of everything behind the scenes, like the patching for the infrastructure, the high availability, disaster recovery, the backups, everything, right? We only need to focus on the database service, right? And we notice that here we have two flavors, right? Managed Instance and Azure SQL DB. Each of them is targeted to a different set or a different, let's say, kind of solutions, right? So Managed Instance is quite similar to what SQL Server is in terms of features, right? We have SQL Server Agent, we have the possibility of, having multiple databases, SQL replication, change data capture, etc. While Azure SQL Database, which, by the way, is one of the first services that was provided in Azure when it was deployed more than 10 years ago, right? It's provide you the possibility of having everything on a single user database. That means that if you have, for example, a code that is referencing tables or objects that are in multiple user databases, well, you have to re-engineering your code because everything has to live on the same user database, right? So this is kind of a sneak peek of what Azure SQL is. So nowadays, SQL Server is everywhere, right? As we said, we have the possibility of running bare metal servers in our data center with SQL Server 2018, for example, right? Also, the possibility of running it in the Linux infrastructure. Since 2017, also have the possibility of running SQL Server in containers, like, for example, Dockers. And eventually, if we need to orchestrate those SQL containers to have a better environment in terms of HA and scalability, we can also run SQL Server on Kubernetes, right? In the Azure platform, as we just said, we have the possibility of running this Azure virtual machine, as well as Managed Instance and Azure SQL Database, and also, as mentioned, SQL Server Edge for targeted to ARM devices, right? So to close up this segment about Azure SQL and this part of infrastructure as a service and platform as a service, right? We can say that most important thing in the Azure world, right, is this concept of scalability, right? Any of these Azure SQL products and services that we mentioned till here has the possibility of scaling up and down in a matter of few clicks within the Azure portal, right? So if, let's say, we need more horsepower, right? Compute power, better disk, more virtual cores, more memory, etc., we can just go to the Azure portal, and in a matter of few minutes, with few sliders, we just scale up or down, right? In the on-premise world, to be able to scale a server, right, it's going to take some time and resources, right? We need to contact the vendor, find out which are the processors that fits on that particular hardware, the memory, if there are free slots, if we can improve the disk by adding it. So whatever we do, right, is going, first of all, it's going to take a lot of time, right? It's not something that we can do right away. Right? In Azure, being able to scale up and down, as I said, is really easy and quickly. Right? In terms of business continuity and high availability, Microsoft in Azure provides us with all the things that we need in order to accomplish all those things, right? Including the possibility of handling our backups, right? Having the possibility of having long-term retention as well as geo-replication of our SQL environment, right? Another important thing that I like to mention in the Azure SQL world, especially in the platform as a service offering, is that this is what they call versionless. What is this versionless thing is, right? In SQL Server, how we know it till now, we have SQL Server versions, right? 2008, as we said, 2016, 2019, etc. Every time that there is a major SQL Server version, we need to migrate, right, or upgrade. We need to prepare and validate a bunch of things in order to make sure that our development works well on this area, right? We have to do a hardcore testing, etc. And when we are ready, we move on and do the upgrade, right? In the Azure SQL world, for managed instance and Azure SQL database, right, there are no versions, right? It's versionless. So it's just Azure SQL, right? So we won't have version in the future. So we won't need to do this, validation every time that there is a new version, because again, Microsoft is taking care of everything behind the scene, including the patching and the features upgrade. Does it mean that since there are no versions here, this is a static version and there's not going to be improvement in terms of bug fixes or new features? Absolutely not. It's the other way around, actually. Microsoft tries everything on Azure SQL first, and then when it's ready, when it is mature, it's moved to the SQL Server product, right? So when we talk about performance capabilities, right, we always refer to the same things: CPU, memory, and disk, right? So you can put the order that you like, but these are the three most important things that we need to, set up correctly, define correctly, and monitor, right? So we can find out if there is a performance problem with any of these three components, right, within our environment. Also, in terms of tasks that we need to do in order to maintain the reasonable performance or a good performance, right, that never changes. And we still need to take care about the updating the statistics, maintaining the indexes in terms of reorganization or rebuild of those indexes, right? And now we're going to start focusing on how we're going to do the monitoring and the troubleshooting on this modern SQL environment, right? And these are some of the things that we're going to be focusing today. First of all, we have this concept, this new concept that Microsoft has, that we can set up a set of features, right, that will constantly check and evaluate the performance within my user database. And if it detects that is something wrong or something that is off the baseline, right, it will take the necessary action in order to correct the behavior right away, right? We're going to see some specific features and some demo about this, right? It's also provide with all the toolings that we need in order to do a proper monitoring and troubleshooting. And with that, we have dynamic management view, right? Those are these read-only objects that we have within SQL Server, in where the engine is telling us what's going on, right, under the hood, in terms of active transaction, in terms of sessions, in terms of usage for indexes, in terms of blockings, in terms of everything, right? We have this set of DMBs, right, that we can query all the time. Every single solution to do monitoring on SQL Server, if it is a free solution, if it is a community-based solution, or if it is a paid solution, all of them relied on dynamic management views and functions, right? Extended events, which is this possibility of doing, I like to call it Profiler 2.0, right? Which is in where Microsoft is focusing all the investment in terms of, monitoring to see if there is something that we need to trace in our SQL Server environment. Lightweight query profiling, a feature that we're going to go deeper in a few minutes, which is available in SQL Server and Azure SQL since a couple of versions ago. Okay, as I said, dynamic management views, right? In Azure SQL, we also have all the common DMBs, but there are a set of them that are specifically for managed instance or Azure SQL database, especially to adjust the behavior of, being able to have the database in some sort of autopilot, right? So there are some specific DMBs that will be exclusively for each of them, but the 90+% of, the common ones are there. So when we go to these performance features, from this point onward, we're going to focus in on this one. Query Store, right? Which is available since SQL Server 2016. Automatic query tuning, which is something that was added at the top of Query Store. Adaptive query processing in 2017 that then was rebranded and, added another set of features called intelligent query processing, right? Column store and in-memory and Tempdb metadata, which is new in 2019. So going to this concept of intelligent performance, intelligent database, right? Remember this, process that is constantly checking all the activity, let's call it activity, within my user database, right? And if there is something wrong, adjusting it on the fly, right? To start with that, we're going to be focusing first on Query Store, right? What I like to define, how I like to define Query Store is like, this black box on the planes that keep track of everything that is related to a particular flight, right? Well, this is kind of the same, but, for a user database, right? Again, starting since SQL Server 2016, we have this feature Query Store that in SQL Server is disabled by default, but in Azure SQL is enabled by default. That means that if you create a brand new database in SQL Server, this feature is there, but you have to enable it, right? In Azure SQL, when you do a create database, for example, right, this feature is enabled by default. What can we do with Query Store? Well, this feature will collect all the runtime statistic and all the execution plans for every single query store procedure running within that particular user database, right? We'll store it, right? And with that, we can take several actions, right? One of them is, use it as a performance monitoring tool to understand which are, for example, the most heaviest processes running on my user database, right? Note that I'm always saying user database, right? This is not something that you enable for the whole instance, right? You can have one instance where you have 10 databases and Query Store enable it in just one or two, if you would like to, right? So you can keep track of every single, query store procedure, everything, and you're gonna get all the execution stats, right, in terms of, for example, duration or resource usage, like, for example, read, writes, Tempdb, allocations, etc., and all the plans as they were changing along the way, right? You know that when you execute something on SQL Server, what it's going to do first is will compile this code and will store with the plan cache, right? That it's going to be reused in the following execution, right? When SQL does that, it's going to store asynchronously, right, the plan in the query store schema. Then it will execute the code, the procedure, for example, right? And after the execution, it will store all the runtime statistics, right? How do we enable query store? Really easy. We just go to the database, we go to the query store option, and then for the operational mode, we just enable it from there, right? Common scenarios in where we can run query store. Well, first of all, just to do performance monitoring, right? Then for those cases in where we have to do migration and upgrade, and we would like to keep track to all our execution if there are any regressions, right? And we need to, identify them to take the necessary actions to, for example, rewrite something or again, do something. Well, we can see it there really easy. In SQL Server 2017, Microsoft added additionally to the possibility of storing the plan and the runtime statistic, the possibility to capture and store all the weights, right, within the user database. So we have all these three components within the query store repository. What can we do also with that? Let's say that, for example, we identify that one specific store procedure has suffered a regression, right? And we're going to see it in the dashboard that it was running in a certain amount of time, and suddenly it went off the roof, just taking 10 times more in terms of the execution. When we go to the query store, we notice that the plan has changed because of any reason, right? Could be multiple reasons. What we can do here is when we identify this, we go to query store, right? And we force the previous plan or any of the previous plan. So the same execution for the following execution will be forcing the plan to be the one that we set manually, right? That means that, for example, if we are running something and then it changed the plan, right? When we identify this, we go to query store and we fix it manually, graphically from the user interface, or using any of these store procedure, SP query store force plan, or we can unforce the plan, right? We will see it in action in a minute, right? So again, this is helping us to maintain the performance more predictable, right? So in this case, for query store, we have to take these actions, right? So here there are some best practices for query store, right? How to use it, right? We can move on. In SQL Server 2017, Microsoft added an additional layer, which is called automatic query tuning, which means that when we enable query store and then at the top we enable automatic query tuning for a specific user database, right? If the engine detects that there was a regression on the execution, it will automatically force the last known good plan. That means that without us doing anything, it will revert to the previous known good execution plan, right? So, in 2016, we have to identify the regression and manually, force the plan. In 2017, if we enable automatic query tuning, right, SQL Server will take care of everything, right? Doing this automatic plan correction. This is a feature enabled in available since SQL Server 2017, right? So how this works? Basically, it will be checking constantly the query store repository, adapting the plans, and then verifying if the plan is if the execution or the runtime is better, right? So here is how it's gonna look like in terms of a plan regression, right? We are, having a constant execution time, and then suddenly it's go to the roof because, again, the plan changed, right? So what this is gonna do? Well, automatically will force to use the last known good plan. In Azure SQL Database, there is something quite interesting, which is also the automatic index management. This is only available in Azure SQL Database, right? If we go to the portal and we enable this automatic index management option, we have the possibility not only to have automatic query tuning, right? But also SQL Server will detect if our workload is requiring to create new indexes, right? And if we enable this option, right, it's going to be creating those indexes on the fly, right? And then when those indexes are not longer needed, it will drop those indexes on the fly, right? So considering that like this is like a deviation checking if there are, if the workload has a missing index, and if there is one, it will find the right spot in terms of time to create the index. And when it's no longer needed, it's gonna drop it, right? For us that are coming from the old school, just leaving the possibility to SQL to create and drop indexes without us, being in the loop, it's a little bit risky, and it could lead into some blocks, etc. But believe me, this is doing a very good job. Also, in SQL Server 2017, and as part of this initiative of intelligent performance, Microsoft has introduced what is called adaptive query processing. What is this adaptive query processing? Well, you know that when you run a SQL Server code, it gets compiled, it come up with a plan and store it in the cache, right? Before 2017, that plan was completely static, right? This means that the plan could have some problems, like, for example, the memory grants, right? But, it's the plan that was generated, so it's going to stick with that plan until, for some reason, it get recompiled or come up with another plan, right? Since 2017, as I said, and with this feature adaptive query processing, we have this possibility, right, of SQL Server coming up with the plan, storing into the cache, executing the code, but then if it detects that the plan has some problems, right, the execution will provide a feedback to the engine, and it will adjust the plan on the fly for the upcoming execution, right? So again, the plans are not be static anymore. It will have the possibility to be adjusted on the fly in order to maintain a good performance, right? This is really interesting because without changing any code on our store procedure, our coding, right? SQL Server will take care of this automatically, right? And there are a set of possibilities on this query plan feedback or adaptive query processing in this case, right? One is, as I mentioned, memory grant feedback. We're going to see it in action. Then there is another one called adaptive join, which basically will use one join or other type of join depending on the amount of rows that is returning each of the lift for the join, right? That is in SQL Server 2017. But then in 2019, Microsoft added a superset of features to the adaptive query processing. It's rebranded it as intelligent query processing with the same concept, right? Being able to adjust the plan based on a feedback that we receive, right? And with that, you see in the slide here, the ones that are in bold are the ones that are at the top of 2007 and 2019, right? And the ones with normal or regular fonts are the ones coming from 2017. So besides the ones related to memory grant feedback or adaptive choice, there is one which is quite interesting, which is the scalar UDF inlining, right? You know that when you create a user-defined function, you can get quite creative, let's say, and within the function, you can put a lot of business logic, right? And then you put that function in the select or, within the predicate, right? And you know that SQL Server is not doing so well historically with the UDF, right? Well, in SQL Server 2019, as part of intelligent query processing, right, for certain types of UDF, the ones that are inlining, right, Microsoft also give us the possibility of compiling the guts of the scalar UDF, right, and then add it to the main plan. We're going to see it in action in a few minutes. How do we enable all this beauty, right? Well, it's extremely simple, right? We only need to change the compatibility level for our user database, right, to 140 if we want to use it as 2017, or 150 if it is SQL Server 2019, right? So with that, all these features, right, for intelligent query processing are enabled and we can take advantage of, right? Then eventually we can disable some of them if we detect that there is some regression or problem with that. But by default, just changing the compatibility level, right, we can use all these features. The other one that I like to mention is lightweight query profiling. This is a feature, right, which is new in SQL Server 2019, right? And it's for those cases in where you imagine that you have this report that runs every morning and normally takes 20 minutes. One specific day is taking, forever, right? You should arrive to the office and you notice that this stuff is still running. So how do you know at which part of the execution we are at, right? If it is at 10% of the execution, 50%, or 90% that is about to finish. Knowing this information, you can actually take the necessary actions, and you will know which kind of actions. Maybe you need to kill the statement if it is in the initial execution part, or maybe you just wait a little bit more in order to make it finish, right? With this feature, right, what SQL Server provides is the possibility for every single query workload running in our instance, right, this value of estimated query progress, which is a percentage from 0 to 100, right? So you will see at which progress, at which percentage of the progress that particular query is, right? And knowing that, as I said, you can take better decisions, right? This lightweight query profiling is enabled, as I said, in SQL Server 2019 and Azure SQL. Microsoft added also the possibility of enabling lightweight query profiling in SQL Server 2016, Service Pack 1, or 2017, but it's not enabled by default, right? We have to enable a trace flag 7412 in order to make it available for our 2016 or 2017, right? And then, you know, in SQL Server 2019, Microsoft added this concept of Tempdb metadata, right? You know that if we have a workload which is Tempdb intensive, like for example, is dropping and created temporary tables quite a lot, right? Well, it's adjust the in-memory technology, right? Which is a technology which is available since since several SQL Server versions, right? But for the user databases, right, and for the tables, in that case, it's allow us to store the metadata for the Tempdb temporary objects, right, in memory. And with that, we solve the problem of doing contention on the Tempdb, right? You will see that for the Tempdb intensive workload is really easy, right? To see how we don't have latches anymore. We're going to see it in action in a minute. So let's see all this in a demo, right? So let me jump to my virtual machine here. So here we go. So let's start with the lightweight query profiling, right? Here I have my SQL Server 2019. I'm on a virtual machine in Azure, and I will enable include live query statistics, right? So when I do this, when I do this, I enable include live query statistic. So when I execute my code, note that up here we see the query progress in the live query plan, and up here and down here we see the estimated query progress, right? Again, we see at which point of the execution we are at, and we can take, as I said, better decisions here. All right. Let me just stop this one and run the one at the bottom. When I run this, you see how we have here the estimated query progress, and it's moving, right? 16, 17, 19%. So we can see it here, right? Really easy, and as I said, with that, take the right decision in terms of what we do next, right? So this is lightweight query profiling. Then we will do query store. And remember, I mentioned these features are for SQL and Azure SQL. So in this one, we're going to be doing it on a managed instance, right? Here I'm connected to SQL Server 2019 on a VM, Azure SQL Database, and also a managed instance. This particular demo is for on a managed instance. So what I did here is I create a brand new database, right? And since this is Azure SQL, and as I said, these features are enabled by default. Initially, I just disabled just to save some, remove some of the garbage or the noise that we may have. So then I create a table with 3 columns, right? C1, C2, and C3. Then I create a store procedure, which is basically doing a select on that table based on a parameter, and then I enter a bunch of random data to my table. Then finally, what I will do is I will, or the next step will be to enable query store, right? Before doing that, so I just going to do a select of my table, so you see what I have here. So I will enable query store at this point, and now what I'm gonna do, this table, when I created initially, it has absolutely no indexes, right? So it's a plain heap table. So I will execute my procedure 20 times. Okay, it just got executed. I go to my database, I go to query store here, and here is where we have a predefined set of reports, all right? So I will go to this one, which is top resource consuming queries. And since this is a demo instance, it's only me, it's only catch this store procedure, right? So we have the graph here in terms of the execution. We have the query plan that was captured. Here we can switch to this view and find out that it was executed 20 times with a minimum duration of 7 and maximum duration of 10, right? We have other data here like when it was the first execution, etc., etc. So what we're gonna do next is we will create an index on one of the columns, right? And then we will execute the same store procedure once again, right? When we go back to query store, we go to the chart here. Note that now there is, for the same query ID, right, which is 1, there is another plan. So when we switch from one plan to the other, we see the difference, right? This one is using the new index that was created. And in fact, the execution time was much, much faster than before. When we go here to validate that, we see that now with the plan ID 2, right, the minimum execution was 007 instead of 7. So way, way faster. Again, we go here and we create another index. In this case, an index that is covering 2 columns. And then we execute our procedure 30 times, right? When we do that, I go back here, we refresh, and now we see that there is another plan, right? So we can go through any of this and see down here how was the shape of each of the plan. When we go to the stat, we see that now there is this plan ID 3 in where the execution was much better than the rest, all right? So let's say that eventually, the new plans are worst in terms of duration, right? What we can do is we can come here, choose the plan that we want, right? And force to use that specific plan in the upcoming execution. So which we're gonna do here. So it doesn't matter what we do next, right? This one, this query ID 1 will be forcing to use the plan ID number 2, right? That is query store. And if we check it with automatic query tuning, right, what we're going to do here is that I'm going to come up with, the performance monitor. And here I have the batch requests per second of my SQL Server 2019, right? So what I'm going to do here is, let me tell you a little bit what we're going to do here. So I have a demo database here in my list, right? Several actually, right? Close this one. And what we're going to do here is we will generate some random workload, right? So we have multiple procedures executing, etc. Right? So when this one is running, we go check the performance monitor, right? And we see that the batch requests per second go to certain number, right? We have, let's clear it and start over. We have like an average of 70 plus minus, right? So what I'm going to do here is I will generate a regression, right? So suddenly there is a regression, and the batch requests per second drop a lot to less than 10 or around 10, right? If we have query store, when we identify this, we go to query store and we force to use the last known good plan. But what we will do here is I will enable automatic query tuning. And how do we do that? I'll show you in a second. I have the auto tune here. I'm not going to use this one. I'm going to use another one better. So the only thing I have to do is, of course, have query store enabled, and then we just do and set automatic tuning, force last good plan equal on, right? So if we do that for our user database, sorry, I have to go to my VM. When we do that, right, now I'm going to execute again my random workload. We go to performance monitor, right? We see the batch requests per second, same as before, but now I will be adding the regression and see what is going on, right? So I generate the regression, and what is happening automatically, right? It detects the regression down here, right? But automatically and right away, right? It correct the execution and went back to the previous execution time, so same batch requests per second in this case, right? Without us having to go to query store and forcing any plan, right? Automatically, it adjusts the behavior without us doing anything. So quite interesting in my opinion. So then let me go to intelligent query processing and show you the one for memory grant feedback. Remember, this is when SQL Server compile the plan, and then after an execution, if it detects that there is something that could be done better, it will adjust it for the next execution, right? So in this case is memory grant feedback. Imagine that you run one procedure for the very first time, and it come up with a plan which is requesting 10 megs of memory, right? And then when you execute it, it turns out that instead of using 10 megs, it is using only 1 meg. So it's not using the other 9 megs, right? You can say, well, it's not a problem. I'm wasting 9 megabytes. It's not a big deal. But imagine that store procedure is being executed hundreds of times per minute, right? You're going to be wasting a lot of memory. And the other way, if the first execution requests 10 megabytes of memory, and then it ended up using 20, it's going to spill up to disk, right? So you're going to have an overall performance problem, right? So that is why enabling, what I'm doing here is enabling the compatibility mode 150, right? Then cleaning the procedure cache. And what I have here to show you is a simple store procedure, which is going to one of the tables and doing a couple of joins, etc. Right? So I have created the store procedure for the very first time, and I will be executing it. I will enable it, include the execution plan, and I will run it with the parameter 8. Right? So when I run it, right, it comes up empty. Right? And when we go and check the execution plan, we have this warning, which is saying at the bottom here, right, detect excessive grant, right, requesting this amount of memory and using not even the 10%, right? So this is wasting a lot of memory. So let's say that this plan is now in cache, and now I will execute it again, but with a different parameter. In this case, instead of 8, I will be using 9. So when I run it, right, notice that it's going to return something, right, and it took a certain amount of time. So when we go here, now we check that there are warnings everywhere, right? Memory grant decrease in this case. Spill to disk because of the sort. Now, also spill to disk because of the join, right? And that was because it requests memory that is not enough for this execution, right? But let's see what happened on the next execution. So we're going to run it again, right? Notice that this time, instead of taking 4 seconds, it took 1 second, right? Of course, it returned the same amount of rows because there was no code change, data change, nothing. And when we go to the execution plan, right, this time, all the warnings are gone. And that is because, it detects this memory grant issues and then adjusts for the next execution. So if I run it again with the parameter 8, right, I'm going to run it. When I check the execution plan, again, we have the memory grant feedback. But if I run it again, right, it's gone, right? It's adjusting on the fly the memory. And same here, right? I'm going to run it again with 9. It's going to come up with all the warnings, taking 4 seconds, right? And when we run it one more time, right, it's faster, way faster, actually, and, with a clean plan in this case, right? So this is a memory grant feedback in intelligent query processing. Then we have also the adaptive choice. And again, I'm going to enable the include the actual execution plan. We're going to do, as we did before, just changing the compatibility level and cleaning the procedure cache. And I will run this join. When we do the join and we go to the execution plan, see that now we have this new operator called adaptive joins. That means that it will use a different kind of join depending on the amount of rows that each of the tables returns on the specific inner join, right? So this is also quite interesting. And the one that I wanted to show you is scalar UDF inlining, right? What I'm going to do here is I will create a scalar function. This function is quite simple, actually. It's going to return, your category if it is, regular, gold, or platinum, depending on the amount of miles that you enter, right? We check and this is an inline UDF, right? So it could apply here, right? So if I change the compatibility level back to 130, SQL Server 2016, and we run this, see the select is adding our function is here. So we're passing the customer key, and with that, we're going to get if it is regular, gold, or platinum, right? So if we enable the execution plan here, you see that my plan is doing the compute scalar and is not giving it any weight, right? But if we change the plan to 100, the compatibility level to 150, right, and then we run the same select, see that now we have the plan for the scalar function embedded into the main plan. And with that, of course, we can do much better in terms of performance, right? So really, really good features out of the box without any code change, right? So we don't need to go and refactor the whole store procedure, the whole application is all in there, right? Without any change, right? We have all this benefit immediately. Mm-hmm. All right, so we are approaching the end here. So let me go back to the slides. Okay, so here I'm leaving the link or the QR code for the official documentation for whatever is new in SQL Server 2019, not only the performance features, right? But all the features in SQL Server 2019, the ones related to high availability as well. Here, another link for the Azure SQL fundamentals, right? All the things that we mentioned about Azure SQL, right? And how to be prepared for the Azure SQL world. And with that, we just finish the presentation. Right? I'm free for questions. Again, you have my Twitter, my LinkedIn, my blog, my email, so feel free to reach me. I believe I'm gonna stay after in one of the roundtables for more questions. So with that, thank you so much.
Yeah, awesome. Oh man, look at that. That's a guy who has been around the block there. You're showing off a little bit there, Javier. You're a wanted man.
Keeping me a little bit busy, right?
That's right.
These crazy times.
So, for those of you who don't know, I feel like I need to remind folks. So, we have our podcast. So, Javier's claim to fame is that he was the very first interview that I did, right? There in Argentina. So he helped me kick it off, and so I'm appreciative to you and circling back ultimately to SQL Trail again. Now, one of the things that I wanted to ask about, and I think perhaps to give some perspective to some of these folks. So in terms of adopting the Azure pieces, I guess all the pieces that you showed, the adaptive query tuning, right? The query store is all available on-prem, right? Mm-hmm. But I guess maybe take us through a little bit just in terms of the why you decide, or Mediterranean shipping company perhaps, what kind of decisions you go through just to decide, hey, we're going to keep this on premise, or we're going to use cloud, we're going to leverage cloud to do this. Talk to me about, is it a feature issue? Is it an availability issue? What are sometimes, how do you go through that process?
Okay, so the first thing to mention here is that Azure SQL is just SQL. So it is the same, right? It is exactly the same. I've been around with SQL since I don't know how many years. I used to have hair. I believe you too. And all
We're going to start a club
in terms of doing monitoring, troubleshooting, etc., is exactly the same before than now. Again, all those pillars of CPU, memory, and I/O remains the same, right? Maybe it changed a little bit the way that we connect and a few things, but again, it's just SQL. What are we doing these days? Well, basically, we are in the process of migrating to Azure, and there are. I mean, we can have another full session on that. Yeah, I mean, I believe that the very first step that we should do as an approach is try to migrate to Azure to something similar to what we have, and in this case, it's a virtual machine running at least the same SQL Server version that we are using on-prem. Sure. Is it a lift and shift migration? Definitely not, right? There are a bunch of things to be adjusted because well, it's not only SQL Server. There are a bunch of other things around, right? So, but I mean, the gut here or the core is SQL Server. So is the first thing to do, to migrate to a VM. Then, my advice is start looking for the other options like managed instance or eventually Azure SQL Database. Right? For Azure SQL Database, I always like to say that if today I have a request to create a brand new application that will require a relational engine as a backend, the very first option that I will check today is Azure SQL Database, right? If instead I need to migrate an existing legacy application that's been around for many years and is kind of critical, etc., I will go to a VM running SQL Server, but immediately I will also check the possibility of running it as a managed instance, right? Because all the benefit of not having to take care of, setting up the availability groups. So you don't have to do create the two virtual machines at least with the window cluster and all the logins in the Active Directory, blah, blah, blah. With managed instance, you just have it with 3 clicks, right? And it's almost 100% compatible with what you have in SQL Server. So definitely, to me, is the way to go, right?
Gotcha. Okay. Yeah, very good. And then I think, and so all of the features that you demoed are available with on-premise features as well, right?
Oh yeah.
That's good.
Yeah. Starting with Query Store in 2016, where Microsoft took this approach of intelligent performance. Definitely, they were adding stuff at the top of it. So it's available everywhere today.
Very good. Very good.
All right.
Thanks again for being here with us, Javier.
Thank you, Carlos, for the opportunity to present here, and looking forward to be in person at some time soon.
At some point, yes, that's right.
SQL Data Partners.